Hello students, hi, welcome back. So in this part, we will be discussing about previous year JEE questions, AAPMT questions and AEEE questions. So this part is one of the most important because I will be discussing about all the previous year questions and you will be getting an idea how generally a question can be asked from this topic of aldehydes and ketones. Right? Why to waste our time? Let's start with that part. Previous year questions, IIT Jee questions, AAPMT questions and AEEE questions. So the first question, right, here we have a first question. The first question asks us to find the correct order of the reactivity of, right, your Grignard reagent phenyl magnesium bromide, and there are other three ketones. I mean, you have an aldehyde here in the second option and 1 and 3 are the ketones. You actually have to find the reactivity of this Grignard reagent with this set of aldehydes and ketones, right? So, what is the main concept? The main concept is that aldehydes and ketones undergoes nucleophilic addition reactions. That means, for example, this carbon is positive and this is negative. And remember, higher is the partially positive charge on the carbon, higher is its thirst to attack with the nucleophile. Again I am repeating, higher is the partially positive charge on the carbon, that means higher that carbon is available for your nucleophilic addition reaction. That means, for example, I have a nucleophile. A nucleophile will attack this carbon only when that carbon is having a partially positive charge. So remember now, there is an aldehyde here, there is a ketone here and there is also ketone here. So higher is this partially positive charge, higher is the extent of nucleophilic addition, isn't it? Okay. So now we will see in which of this the partially positive charge is higher. So the first, you have phenyl groups. You know that phenyl groups show Plessis effect and the extent of Plessis effect of phenyl groups is very higher. That means they actually donate electrons, right? They actually donate the electrons towards the carbon. That means phenyl groups are actually reducing the partially positive charge on the carbon, isn't it? And to the contrast, there are methyl groups. And methyl groups also does the same thing. They also donate electrons. They also donate the electrons because of its Plessis effect. So what is also happening here? The partially positive charge is getting affected. So the higher, this is higher, but this is lower. Right. Now here there is only one methyl group, but the other is hydrogen. Here in the aldehyde, there is one methyl group and only hydrogen. So because of this hydrogen, the Plessis effect further decreases, right? And since the Plessis effect decreases, this will be very low. So, right, the capacity of this methyl group and the capacity of this hydrogen to donate electrons is very, very low. Now, the concept is lower the capacity to donate electrons, higher is the partially positive charge. I mean, lower is your Plessis effect, your partially positive charge increases, then reactivity increases. So obviously it will be 2, higher will be 2 since it is very low Plessis effect, and next comes here 3, there is low Plessis effect, and next it should be 1 which has higher Plessis effect. So the answer would be C. So this is an IIT Jee question. Next question, how will you convert butone to propanoic acid? What is butone? This is butone and I want to convert this into propanoic acid. right. So logic is simple. If you use tolerance reagent first of all it won't react with ketone. So you can't react with your tolerance reagent. Neither same thing with your failing solution. If you are using failing solution, the same effect, right? Nothing is happening. Now just focus on C. If you focus on C, what is happening is there is sodium hydroxide and iodine, and this is nothing but, if you just revise, you know that if there is a methyl group of the ketone, it undergoes an haloform test, or here it is iodine, then it is an iodoform test. So this converts into your CO minus plus your CHI3. This CHI3 is an iodoform, right? And remember what is happening next, you are using hydrolysis. That means this on undergoing hydrolysis, this converts into propanoic acid CS3 CS2 COH. So the answer is, in iodoform, higher chain of ketone can be converted into lower chain of your carboxylic acid. That is, pure 2-one can be converted into a propanoic acid. The answer is C. Next question. So the compound that undergoes decarboxylation most readily under mild condition, right? So here decarboxylation should takes place, that too under mild conditions. So this concept comes under the concepts of ketones. Whenever you have beta keto carboxylic acids, that beta keto carboxylic acids undergoes decarboxylation very easily. For example, which of this is the beta keto carboxylic acid? Your B is your beta keto carboxylic acid. So hence B is the right answer. So this compound of B undergoes decarboxylation most readily. Remember, under mild conditions. This undergoes decarboxylation under mild conditions only. So the answer is B. Next question, right? So here you have a ketone, then you have a cyanide which is a nucleophile, then you are using H2SO4 which is a dehydrating agent. The question seems to be easy, right? We know that cyanides, the logic should be same, guys. You have a cyanide, that cyanide attacks your carbon, right? And here you have cyanide, and obviously you have O minus, and this can form alcohol, right? You know this, that you will be getting a cyanohydrin. Ketones, when ketones undergoes reaction with HCN, you will be getting a cyanohydrin, right? Next thing is, you are actually not only reacting with H2SO4, right? You are actually not only reacting with the H2SO4. So what is H2SO4? H2SO4 is a dehydrating agent, right? The concept should be simple. I am not hydrolyzing it, I am just using H2SO4 immediately. Remember, I am not hydrolyzing it. Had it been it undergoes hydrolysis, it converts into an acid. But I am not hydrolyzing, I am just dehydrating it with using H2SO4. So obviously dehydrating it forms a double bond or unsaturated compound. So obviously you will get a double bond here. So CS2, CCN, CS3. So this will be your product. So obviously, what is the answer matching this? The answer is B. So it will be CS3CH, CCS3CN. Obviously it is CH. So the answer is B. So this question is logical question because there is nowhere of hydrolysis. That's why your cyanide group still remains intact, because you are adding H2SO4 immediately after the formation of G. Right? So this is another tricky question. So next, Next question is again related to your aldehydes and ketones, but this question doesn't seems to be from aldehydes and ketones because there is a carboxyl functional group, right, COH, and it is present in, right. So here the functional group is COH, and the options are you have picric acid, you have barbituric acid, you have ascorbic acid, and you have aspirin, right. So there is one famous pharmaceutical product which is aspirin. What is aspirin? Aspirin is formed from your phenols, and you use a carbonyl compound in between, and finally you will get an aspirin. So in aspirin you have, this is aspirin, right? What is aspirin? This is aspirin. You have COH here, and you have O here, and you have COCH3. This is aspirin. So hence aspirin is the only compound which has COH functional group. So it is clear that, so what is picric acid? Picric acid has NO2 and NO2 at the 3 positions, and it is an alcohol. So similarly you won't be having, right, the name says it's an acid, but these acids don't contain your carboxylic acid group. So answer is D. So students, after going through the video lectures and video solutions, so you might be still having some doubts, right, related to a new theory or related to a numerical. So what you have to do is just go to our website www.askIITians.com, and on the website just select the tab Ask a Question, and on the right side of the screen you can find Ask Experts icon. So on this icon just select your category. For example, if you have a physical chemistry question, and just post your question. Likewise you can post your organic chemistry question or inorganic chemistry question, and you'll be getting the solution and answer for your question within 24 to 48 hours. So students, in this part we have discussed about your previous year JEE questions, APMT questions, and IEEE questions, and we have understood how generally a question can be asked. So till now we have completed all the parts of your aldehydes and ketones. We have started with the introduction of aldehydes and ketones. In that we have discussed about the structure of your aldehyde and ketone. We have discussed about the IUPAC, naming of your aldehyde and ketone, and also we have discussed about your common names, right, of aldehydes and ketones. And in the last we discussed about the properties, physical properties. Afterwards we discussed all the preparation techniques of your aldehydes and ketones, how exactly you can prepare an aldehyde and ketone from other organic compound. And later on we move to the chemical properties of your aldehydes and ketones. So in the chemical properties we have discussed about the important chemical reactions possible with your aldehyde and ketones. In the last we have discussed some of the previous important JEE questions, APMT questions, and IEEE questions, right. So this is the end of your topic of aldehydes and ketones. I hope you enjoyed all these parts of aldehydes and ketones. So take care, and don't forget to stay tuned to our sessions at askIITians.com. You will be getting all the sessions, all the topics, all the parts related to physics, chemistry, and biology. So we'll meet in the next part of the next topic. Till then, stay tuned. Goodbye. Take care.